go look at this issue of a custom distribution. So, so here we have a table function, and the table function conceptually here is a mapping from temperature to evaporation rate. So I don't want to pretend, it disturbs me aesthetically to pretend that's a distribution. Instead, I'll define a custom distribution, okay? I'll say custom PDF, custom probability distribution function, okay? So custom probability distribution function, and maybe I want this thing to look like this. For it has 0 chance of having something maybe below 0. Hey, where am I? Here I am. 0 chance of having anything below 0. It has a chance of, right, yeah, okay. So it'll have a chance of a relative, this will be a relative thing, so relative value of 1 at excuse me, relative value of 1 at the value of 10. So this will be 10. And then from there to 20, it will be flat. And then at 20, it will, at 30, it will go down to 0 again, okay? So now we have a distribution that looks like that, okay? This is a relative, these are relative values. These don't total up to 1 or integrate to 1 here, but it's a relative thing. And then what we can do, Farhad, is we could create a custom distribution here, okay? We could say custom probability distribution, and this will be as a type, it'll be a custom distribution, okay? And in order to create it, the initial value of it, the value which won't change, is new custom distribution. And as part of that, we could actually give it an argument, okay? Hey, why don't you show the requisite information? Okay, yes. But where's the link to, okay, I could look it up in the help, but I'm just going to pass it. I'm pretty confident that we could just pass it this thing. Okay, so here we can pass it this function. And so basically we've created a custom distribution here from which we can draw, which will exhibit a histogram like this in terms of the count of values here. So if we go in our model and we were to take, create a, how could I look at a histogram created by this thing? Riddle me that in AnyLogic. If I want to create a histogram of values generated by the custom probability distribution, how could I do that? I create a histogram, data here, right? And so I could say histogram test for custom distribution, right? Okay, and we're going to use this to probe it, to actually empirically see, hey, does it in fact generate values roughly with that distribution? Okay, so what's its value going to be? The value of it is going to be custom probability distribution, and then we need to call that, and we do get to return a random number distributed according to this. Okay? And how many intervals do we have? We'll have 100 intervals from 0 to 100, eh? And we will have this update automatically every one time step. We'll just have it do it over time, even though we don't have to. So this thing is going to sample from this custom probability distribution, and the custom probability distribution's Histogram, sort of its underlying relative sort of distribution function that we want it to match is this one here. Okay, so let's do that. Let's run this thing. Let's run this out. We're gonna see if it matches that. We're gonna run it for 100 time steps. Boom. Oh my gosh. With no parameters was called. Well, no random number. Oh gosh. Get. You have to say get random. It looks like. Okay. Okay. Let me go get that. Okay. So what is the problem here? I thought that should work just fine. Okay. So returns a this method uses the random number generator set during construct. Oh, you have to set it during construction. Okay, fine. Throws an exception if it's not provided. Okay, so it looks like I have to do a little bit more information here. Fine. So I need to get a random number generator and probably set that here. So that's what I didn't provide. So let's go up to custom distribution. We'll go look in AnyLogic's help here. And we will go set this. So custom distribution. Hey, okay, there we go. Great. Okay, custom distribution. So we can give it a set of observations, or we can give it a table function. Okay. And then we can do these various gets, but here we need to give it as part of its constructor. I thought, aha, okay, a table function. Oh, it says is not yet set. That's the problem. This custom distribution, this is what I gave it, a table function. It says random number generator is not set after, must be provided in each call to it. Fine, so I'm gonna need to do it here. That's great. Now, how do I get a nice random number generator? That's the question. This dot, so it needs a random java.util.random. Okay, java.util.random, and oh, okay. And what are the options here? Okay. So I'm trying to remember how I get a new random number generator. Anyone remember in Java? It's just not striking me right now. So let me pause this while I figure this out. Okay, so in order to get a new random, there's two ways I could do it. One thing is I could do it inefficiently. I could just say new random and give it some fixed number. But I think it's going to return the same sequence of values. So what it will be actually better is to define one more variable, and I apologize for this affront, one more variable here that's called our random generator. There's probably a better way to do this in AnyLogic, but this is the way I'm going to do it. The initial value for this is new random, like that, okay? And it's of type random. Java.util.random if you want, but because it knows about this built in, knows about java.util. And then, now I've got this random generator, and here I do custom distribution.get, and here I give it the random generator. Why am I doing this? It's because in order to use this method here, it requires the random number generator to be set when custom probability distribution is built. We don't have that, so we have to give it a random number generator here, okay? Although it looks like, there, if only I had read the documentation. You can just do get default random generator. You could just call that. So scratch that, folks. This is one way to do it. This will work, but there's a better way to do it we'll come to in a moment. So let's go do this. And we're going to run this thing, and what we will see is this is accumulating histograms, a histogram of values here, and it's running out. And what we are seeing is the values tend to cluster exactly where we'd expect them to cluster. And they are 0 outside this limits. They rise. If we were to examine this in Excel, for example, what we would find is that so office, this is already binned data, so I should have really binned it in larger bins, but or run it for a longer period of time. Oh man. Okay, there we go. And if we were to look at this as a function of the bins, we could see something like this. It's low in the beginning, rises up, stays high, goes down. If we were to run this instead for 1,000 time units, we would see it much more clearly yet. But as I said, there's a better way to do it, so we actually don't need this random generator. That's one option, but we can do without it. Instead, what we can do is call here, we can call get default random generator. That is what we can do. So in short, we get our custom probability distribution function. We have this. This defines the basic shape of it that we want. We want this custom probability distribution based on this function. And then every time we get a number, we just pass it the default random generator, and it will generate a random number for us. That's great, and we will go and just run this to be verified it works, and we should see a similar thing. I'm going to set this to run longer, run to 1,000 time units, and run it with for that time, and we should see something accumulating that's has a pretty compelling distribution associated with it. Okay, so time is passing quickly. I've been answering various questions here, but oh gosh, table function. Okay, yeah, I didn't. I must have gotten a table function out of range. That's interesting. We'd have to go look at that. It may be that it was from this table function here, or was it from this table function? Well, in any case, we'll close this YouTube.